Hi friends, welcome to my another video. In this video, I will discuss the difference in DEWA regulation and ADDC regulation. This is the part 1 video in series of difference between DEWA and ADDC regulation. In this series of video, we will discuss the major difference between DEWA and ADDC regulation. So let's start. As per DEWA regulation, the power factor to be maintained at the consumer end in between zero point 0.9 to 0.95. But as per ADDC regulation, the power factor we have to maintain at the consumer end between zero point 0.9 to unity. If you will maintain the power factor from zero point 0.9 to 0.98, it is also accepted by DEWA, but DEWA have recommended that it should be 0.95. But as per ADDC regulation, it is recommended in between zero point 0.9 to unity, but not recommended in between any specific value like 0.95. Here I will show you one screenshot which is from DEWA as well as from ADDC regulation. This screenshot is from DEWA and this screenshot is from ADDC regulation. So here it is mentioned that the recommended value for DEWA for the power factor is 0.95. But for ADDC, we have to maintain the power factor in between zero point 0.9 lagging to unity. But DEWA will not stop if you will maintain the power factor at the end of the consumer is 0.98, as the 0.98 power factor is better than 0.95. Okay, so DEWA will not stop you to maintain the power factor 0.98, but DEWA is recommending to maintain 0.5. But in the ADDC regulation, it is simply given a range that you can maintain any point in between zero point 0.9 to unity. This difference is more or less same between DEWA and ADDC. There is a slight difference. That's why I included this point in this video. Now let us move to the other point between DEWA and ADDC regulation. In a radial final sub-circuit may be installed to serve a maximum of 513 ampere switch socket outlet in a room, and maximum 10 sockets are allowed in a ring circuit. Okay, it is meant, what DEWA says? DEWA says suppose there is a radial circuit, then we can add maximum 5 single socket in a radial circuit. We can have 5 13 ampere socket in a radial, and suppose it is a ring, then we can add maximum 10 single socket. For a ring, 10 single socket we can add, and for a radial we can add 5 single socket. As per ADDC regulation, what it is saying, the maximum number of single phase socket outlet on each ring and radial shall be determined according to the anticipated load and uses of the appliances. What it is mean? DEWA clearly saying for radial circuit you can add maximum 5 socket, for ring circuit you can add maximum 10 circuit. But ADDC regulation is not specifying clearly how many socket you can add in radial or ring. It is saying it depends on the load, but general practice is that we can add 4 13 ampere socket on radial and 8 socket on a ring circuit. It is not specified, I will repeat again, it is not specified in the ADDC regulation. ADDC regulation clearly saying it is depending on the anticipated load, but in general practice in ADDC as in the Abu Dhabi, we are maintaining 4 single socket for the radial circuit and 8 single socket in a ring circuit. Here is the screenshot from DEWA and from ADDC stating the same, that 5 13 ampere sockets are allowed for a radial circuit and maximum 10 sockets are allowed for a ring circuit. For ADDC, it is stating same, that the number of socket outlet are determined according to the anticipated load and uses of appliances. But in a general practice, we are using for radial 4 socket and for ring 8 socket in Abu Dhabi. Clear? Now let us move to the other point for DEWA and ADDC regulation. The main earth electrode resistance shall not exceed 1 ohm. But as per ADDC regulation, the main earth electrode resistance shall be allowed till 10 ohm. For DEWA, the maximum allowed main earth electrode resistance is 1 ohm, but in ADDC, the main earth electrode resistance. Here I added the screenshot from DEWA regulation as well as from ADDC regulation stating the same, that the main earth electrode resistance are shall not exceed 1 ohm, and for ADDC regulation the main earth electrode resistance shall be allowed maximum till 10 ohm. Okay, now let us move to the other DEWA and ADDC regulation difference. For MDB incomer rating less than 200 ampere, 1 earth electrodes are required. But and for MDB incomer rating greater than or equal to 200 ampere, 2 earth electrodes are required. What is this? I will explain you. Suppose I have one MDB, so it will have a breaker, incomer breaker. Suppose its rating is less than 200 ampere. Then for this MDB, there will be a earth electrode, earth pit. So the number of pit required is 1. But suppose if the main incomer rating of MDB is greater than 200 ampere, then we need 2 earth pit as per DEWA regulation. As per DEWA regulation, this rule is for 200 ampere incomer of MDB or greater than 200 ampere of MDB. But same concept in ADDC regulation, is that for MDB incomer rating less than 500 ampere, 1 earth electrode required, and greater than 500 for the MDB incomer rating 2 electrode required. So in case of DEWA, when the incomer rating is less than 200, then one earth pit required, and greater than 200, 2 earth pit required. But as per ADDC regulation, this breaker rating is not 200 but it is 500. Below 500, 1 earth electrode required, or we can say 1 earth pit required, and above 500 we need. Here I added a screenshot from DEWA and ADDC regulation stating the same, that if the MDB rating is 200 and above, then 2 earth pit required, and if it is less than 200, then One earth pit is required. One main earth electrode is required when the incomer rating is less than 200 ampere. In same way for ADDC regulation, 500 rating and above, at least two independent earth electrode must be provided, and less than 500 we required only one earth electrode. Hope you are clear now. Now let us move to the other difference between DEWA regulation and ADDC regulation. This is very major difference between DEWA and ADDC. What it is stating, in DEWA, for FDB, the incomer, for final distribution board, the incomer is isolator. In ADDC, for FDB, final distribution board, the incomer is isolator. So in case of FDB, DEWA and ADDC regulation are same. But for SMDB in DEWA regulation, the incomer of SMDB must be isolator or non-auto MCCB. Means this MCCB should not be trip or off automatically. It is like a isolator. But in case of ADDC, the incomer of SMDB must be either MCCB or ACB. So what is the difference? In DEWA, the incomer of SMDB must be isolator, but in case of ADDC, the incomer of SMDB must be any breaker. Okay, now let us move for the MDB case. In MDB case, DEWA and ADDC regulation, the incomer of MDB must be breaker, that could be ACB or MCCB. In case of ADDC also, the MDB incomer must be breaker, that could be ACB or MCCB. So what is the difference between DEWA and ADDC? Is lies in the incomer of SMDB. In case of DEWA, it should be isolator or non-auto MCCB. In case of ADDC regulation, it must be breaker. Now let us move to the other difference between DEWA and ADDC regulation. As per DEWA, only two size of transformer are accepted. One is 1000 kVA, another is 15,000 kVA. But as per ADDC regulation, three size of transformer are allowed. That is 1000 kVA, 1500 kVA and 2000 kVA. Now let us move to the other difference between DEWA and ADDC is that provision for connecting the mobile generator for maintaining power supply under main failure conditions shall be provided in MDB or LV panel with incomer rating of 1600 and 2500. As per ADDC regulation, provision of connecting mobile generator in MDB and LV panel is not mandatory requirement. This is one of the major difference between DEWA and ADDC regulation. I will explain this point. Suppose I have an MDB, okay, and its breaker rating is 1600 ampere. So as the breaker rating is 1600 ampere or above, that could be 2500 ampere also, then we need two breakers. One will be going to the transformer and one will be the provision for the mobile generator. Okay, suppose if anything happened to the transformer, then mobile generator will come and this terminal will be readily available to connect the mobile generator in order to relay the power supply to the building. Okay, so I will repeat, for any MDB which having a breaker rating 1600 or above, it's required mobile generator provision as per DEWA regulation. But in ADDC regulation, such arrangement is not mandatory. Now let us move to the other difference between DEWA and ADDC regulation. As per DEWA, per section in the FDB, maximum 6 MCBs are allowed. But in ADDC regulation, per section 14-way three phase, or we can say 42-way single phase MCBs are allowed. What does it mean? Let me explain you. Here we see this is 1 dB as per DEWA regulation, and this is 1 dB as per ADDC regulation. This dB is a row type dB, and this dB is a pan assembly type dB, or we can say way type dB, split way type dB. Here you see we have 1, 2, 3, 4, 5, 6, 7. 7 ELCB is there, ELCB. Each ELCB is considered as one section. So there is 7 ELCB. So it will meaning this DB has 7 sections. 1, 2, 3, 4, 5, 6, 7 sections. Each sections should have maximum 6 NOS of MCCB. Oh, sorry, MCB. Okay, as per DEWA regulation. Meaning each ELCB can control only 6 MCB. Okay, each ELCB can control only 6 MCB as per DEWA regulation. Now let us see the panel related to ADDC, that is either that is called pan assembly type DB or way type, split way type DB. Here we have only two ELCB, 1 and 2. One ELCB can control 42 MCBs, and other ELCB can control 42 MCBs. In case of DEWA regulation, only 6 MCBs can be controlled by one ELCB, but as per ADDC regulation, maximum 42 single phase MCBs can be controlled by one section. Here you can see that, I will zoom it. As per DEWA, there is one section of ELCB, and that section is controlling 6 outgoing, that is 6 MCB. Here also you can see there is one section, and that section is controlling again 6 MCBs. Maximum it can control 6 MCBs. Okay, but in the ADDC regulation, here you see one section can control 42-way single phase MCBs. So this is one of the major difference between DEWA and ADDC regulation. Now let us move to the other difference, that is in between DEWA and ADDC regulation, is that in DEWA the DB type is row type, okay, and in ADDC the DB type is pan assembly type, or we can say split type or split way type. In DEWA it is row type, in ADDC it is pan assembly type, or we can say split type or split way type or way type DB. Now let us move to the other difference. This is one of the major difference between DEWA and ADDC, and very important. If we will design the FDB as per DEWA regulation, then we have to consider total connected load. When we are designing FDB as per ADDC regulation, then we have to consider total connected load. It means for FDB designing for both ADDC and DEWA, we have to consider total connected load. But when we are designing the SMDB as per DEWA regulation, we have to consider total connected load. But whenever we are designing SMDB as per ADDC regulation, then we have to consider demand load, not total connected load. We have to consider demand load. For MDB, when we are designing as per DEWA regulation, then we need to consider demand load for MDB designing, and as per ADDC regulation also we have to consider demand load for SMDB designing. So what is the difference in DEWA and ADDC? The difference lies in SMDB designing. When we are designing SMDB as per DEWA, we have to consider total connected load, and when we are designing SMDB as per ADDC regulation, we have to. Now let us move to the other difference between DEWA and ADDC regulation. In DEWA, the SMDB will be conventional type. Conventional type. In ADDC, the designing of SMDB must be pan assembly type. Okay, it is a pan assembly type. What is the difference? Here there will be a ready-made bus bar. Okay, and this ready-made bus bar we will assemble in the enclosure. But here the assembly of the bus bar depend on our specific design, but here the bus bar will be readily available in the market. That design of SMDB is called pan assembly design, and for DEWA that design of SMDB is called conventional type. Now let us move to the other point as per DEWA and ADDC regulation. Here I will show you one very important point. This is the load schedule for DEWA regulation, one of the sample for load schedule as per DEWA regulation. Here you see there is a rating of ELCB, incomer, circuit number, circuit name, the circuit rating, wire sizes, ECC sizes, room detail, load detail, okay, wattage per for the loads, then the load per phase. But if you will see the sample for the ADDC regulation for the load schedule, you will find here diversified load. Here you will find diversified load. In DEWA regulation, you didn't find this diversified load or demand load. But in ADDC regulation, you find this one in the final distribution load schedule. Here we have to write the diversified load for each individual load, and we have to sum it and we have to put in the SMDB. As I told you, for ADDC regulation, in the last difference I told you, for ADDC regulation in SMDB we have to design the SMDB based on the demand load, but in DEWA regulation the SMDB designing is as per total connected load. That is the reason in DEWA regulation FDB load schedule template there is no column for the demand load or diversity load, but in ADDC regulation, as we need demand load for each FDB in order to design SMDB, that's why we have a separate column. I hope you find this video informative. This is just a part 1 video in series of difference between DEWA and ADDC regulation. There will be some more parts will come like part 2 and part 3. In that we will cover other major difference between DEWA and ADDC regulation. So stay tuned all and watch my all video. If you like this video and find this video informative, then please subscribe my channel, hit the thumbs up button and share my video with your electrical friends. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.